So I'm working on my calibrator again because I had a problem with the reference board. Again, one of the faults I had originally was that it had a voltage error of about 6%, so at 1 volt it put out 1.06 volts, for example. That came back. I was using it absolutely fine. It's been working fine for a little while, and then suddenly it just failed. It's just not happy now. It's doing the same thing continuously. It doesn't matter what I've done, I can't get it back. I've obviously gone digging to find out what's wrong with it. As you can see, I've got my STS104XE set up on here, using all 4 channels. Really, I need 5 channels. So the lighting is as good as I can do right now with this. So I've got my meter here set up to DC volts on the output of the calibrator. I've got this monitoring 4 test points on the reference board, and I will explain what's going on. I'll turn it on, demonstrate first. Turn the output on, do 1 volt, and as you can see we get 1.06 volts. Here you can see a whole bunch of waveforms. Stop that so I can turn the calibrator back off and I can show you this. So this top waveform here on channel 1, that is the signal from TP4. The pink waveform, which is channel 2, that's the signal from TP5. The cyan waveform from channel 3, that is from TP3. And the green waveform on channel 4, that is the link 8, or K8, which is basically the output that goes to the filter, which is the actual signal which gets put out in a way. So I've just zoomed in a little bit on this, it just makes the waveforms a bit clearer to see. So you can see that TP4 is high, TP3 and 5 are both low. This is actually wrong. So here is a page from the service manual, which is section 6.5.8, which describes the functioning of this particular section of the reference. I actually hooked my probes intentionally in the same order as they are on this page here, so we could actually do a comparison between the waveforms here and what we're getting on the scope. TP4 and TP5 should both be high at the same time. One's an N channel JFET, another's a P channel JFET. They are in this system here. This is TP4 switching on the negative going JFET here. So that basically grounds this link through link 8 for the output, so that's basically grounding it. And TP3 comes from this side, and TP5 is this side, onto this JFET. TP3 and TP4, because they're both N channels, they must not be at the same time. And because this TP5 is going to P channels, that has to be on at the same time as TP4 is on, because P channel, you need power to turn it off, otherwise it's conducting. So that turns that one off at the same time as this one's turning on. So what's actually happening is that this JFET is turned on, and that JFET is not turned off. So these actually describe the waveforms here and the actual switch states, so you actually understand what switch states are. So when TP4 is high, it should be this state here. So TP4 should be on, that switch should be off, this switch should be off. And that means that TP5 must be high to turn that switch off. And as you saw on the waveforms, it is not off. It is on. Well, I should say it is a low state on here, which means the JFET is conducting. So therefore the switch is effectively on. I think I found a problem here. One of these flip-flops appears to be broken, or it's being driven incorrectly. The switch state is inverted. TP5 state here is inverted. It's just wrong. So TP4 high, so that's that state there. Then TP5 should be high as well. It's not, it's low. TP3 should be low, and it is. And then link 8 should be kind of high. It's low. It's inverted. So because TP4 is the one that pulls the signal line down, if that's high, this should be low. So that's the state here. TP4 is working correctly, but what's happening, because that is on and this drive is not on, it's still a low state unless both the drives are on. Or in fact, what's actually happening here is only one of the JFET pairs are turned on. Both pairs should be turned on, only one of them is turned on in this particular state here, which is why you do have a high voltage, but it's not the right one, because this one should be low to enable the second pair of JFETs. So when this one here is high, that's turning on the N-channel JFETs here, which is Q32, Q35. So those are on, but what it should actually do, it should be turning on, is it like a 5 microsecond delay. I haven't actually checked the timings yet, but it's basically a 5 microsecond delay between the turn-ons. So this one should go low, then this one should go low as well, and then this one should go high. But that's not what's happening. TP5 is wrong. It's inverted from what it should be. What's causing that? Right, so this is the circuit diagram for this particular section of the reference board. I'll explain each section. We've got these isolating transformers up here in each driver. So these are driving the flip-flops in each section. There's 3 flip-flops on this particular side. This is the high side, there's also a low side. Here is the reference board, and this is outputting kind of a reference voltage. I'll explain why it's kind of in a second. So what should actually happen is you should have the reference voltage coming down to source or drain of the JFETs up here. Now you have 2 in series and also bridged across here. This set of flip-flops should be basically switching this JFET pair on and off. Now these are N-channel JFETs, so when this is TP3, so when TP3 is high, those should be on. I'm going to jump down to the bottom here. We have another drive system, another flip-flop, and this is TP4, and this should be switching on the ground JFET in an alternating state with the other ones. So if these are on, this should be off, and vice versa. And they are. We saw on the waveforms that those are switching correctly. Over here is TP5, and that's driving this JFET, which is a P channel, as I said. So that should be on at the same time as this is on to turn that transistor off, because these will conduct when there's nothing driving the gate. So when the gate goes high, it turns the device off, so it's inverted in that way. When TP4 is a high level, TP5 should be at a high level, and as we saw from the waveforms, it's not, it's at a low level. So this drive from this section is inverted. Now the link 8 voltage, which we saw, that waveform there, which is spiking on and off, that's there. And this thing goes through the filter, which smooths it out to the appropriate level we want. So it's basically using the mark space ratio to work out the actual voltage. So obviously the more time it's on for, the higher the voltage will be. This section is what we're looking at here. Now the interesting thing is that this lower section here, the TP4, that is working fine, it would seem. And these 2 drive systems here, these isolation transformers, they are in parallel together. So the drive side, the primary side, they're in parallel. So if one is on, they are both on. Which means we can eliminate a problem with the drive circuitry prior to the isolation transformer. Because the phasing of TP4 is correct. One of the other little things here is that the voltage reference is fed into this center of the trap, or the transformer. The TP4 is negative reference, goes to ground on a center tap, and the TP5 section goes to the voltage reference. Now what's happening though is that when we get this fault where this transistor's turned on and these are turned on as well, it's shorting out the voltage reference. It's actually killing that voltage, it's going to nothing. It's shorting it out, it's actually stressing the reference, which is why I don't leave the thing on for very long. I discovered that quite late on, unfortunately, so I may have already stressed it, but anyway, we'll see how that goes. Because that is a reference to the voltage reference, could be because that voltage there is dropping off, it could be inverting the flip-flops because that voltage is wrong. Instead of being a positive voltage, it's a 0 volt, so therefore it's inverting it that way, and it's kind of stuck in a loop. The frequency is the same because all 3 sets, they've all got 125 kilohertz frequency, which is what it's supposed to be. Obviously we've got supply rails as well, so up here we've got a plus 36 volt rail, and down here we've got a minus 15 volt rail. So I should also verify that these 2 rails are present. Another thing is we've got the voltage reference popping up over here as well. So we've got voltage reference here and over here. So if the voltage reference dies, that may make this invert. It's a bit like a chicken and egg situation. Which one is going wrong first? Is the voltage reference being dragged to ground and then it's making this invert, or is it this is inverting then making it drag to ground? Because if you think about this, if the voltage reference dies and this is then inverting the states of the flip-flops, that could then make the signal here invert, give us the impression that the flip-flops are what's wrong. But if the JFET is shorted, one of these JFETs is shorted, because it's killing the reference, it could be confusing things. The fact that this will go high at this point, this link 8, that will go to a high state, basically means I can rule out Q37 as being bad. Because if this never went high, then I'd say, yeah, Q37 is probably shorted. But the fact that this is switching at LK8 means, okay, that one there is probably fine. Now the problem is, I'm hoping that if it is a JFET problem, it's not one of these J108s, because these are a matched set. Anyway, I've managed to find some parts online, so I've ordered them. So if it is a JFET, at least I will have spares. It just may mean it's not as good as it should be if I have to replace one of these J108s. I'm probably worrying about nothing. I'm going to dig into the flip-flop first, see what's going on here. It's like 2N3904s, 2N3906s, It could just be a bad solder joint or a cracked trace. It could be something like that. Don't forget, when I first had this fault, identical symptom, I resoldered the board and the problem went away, and then it came back. Probably about 30 or 40 hours usage, the problem came back and wouldn't go away again, which is what I've got right now. But I have resoldered the board again, and I've done the whole board, resoldered every joint, didn't change anything. I wanted to rule that out completely as a simple resolution. But it could still be a cracked solder pad on a trace, so the solder pad is detached from the trace. Could be something like that, or a cracked trace somewhere. Either rule that out or confirm it. And it's a simple section to try and diagnose. I could always probe on the transistors themselves, so I could always potentially do that. And actually check the switching of the transistors and make sure they're actually switching like they should be, based off the signals they're getting. Maybe there's one that's stuck. Don't know. So I was looking at the waveforms, realised that the minus 11 volts may not be in the waveform. So on the TP3, it never went to minus 11 volts like it's supposed to. But when it was not faulting anymore, the minus 11 volts was there. I was thinking, could it be the negative 11 volt rail has got an issue? So I thought I'd start looking at that more closely. I looked around where it could potentially be in that TP3 circuitry, and I traced it back and I found potentially a cracked trace right there. Now that is on the resistor. It's one of these special standoff resistors. So this resistor just here, right, that one there, it's on these little standoffs. No, it's not in focus, sorry about that. And the top pad seemed to be cracked. So I actually think that is a crack. Now obviously I've been scraping it to try and get the solder mask off, but I can actually see that line before I started scraping. So I've changed the lighting on it as well. You know, it stands out quite well there. There you go. There you go, it's a bit of camera shot, and you can see me in it too. Right, so there you go. There's that line right there, and that's what I could see through the solder mask. If you change the lighting, you know, there you go. You can still see it looks fairly prominent. So I'm pretty sure that is what my problem is, because that resistor passes the minus 11 volts through to the diode and two other resistors, which basically form on the negative 11 volt side of that flip-flop circuit. So I'm going to resolder this and we'll see if it stays stable. That cracked trace, which I think was cracked, I'm not 100% sure it's cracked, that didn't fix anything. I resoldered that, problem didn't go away, so not that. At least I've eliminated something which could have potentially been a problem anyway. I'm still trying to figure out what is actually happening here. What I've now done is I've cut a track. I really hate cutting tracks. It's like the absolute last thing I will ever do to anything is cut a track. I really don't like doing it, but I've had no choice. I've had to isolate two parts of circuitry from each other. Reason being is I'm trying to determine which part is causing the problem, because it's basically like a loop. Unless you break into the loop, you can't really diagnose it. What I'm actually looking at is the reference which is used in the flip-flops. So it's two flip-flops are using the reference as a reference point for the flip-flops, right, for the voltage controls and for the inductors and stuff on there, like electrical transformers that's on there, the input transformers, using reference as a center tap. And that flip-flop is one which is giving all the trouble before with it being out of sequence. It's, you know, the reverse polarity, what it should be. I actually probed all the flip-flop circuitry, and I found that both flip-flops, or both transistors, are turning on and off at the same time. They're not actually alternating, they're both coming on and off. And I'm thinking, okay, well, one side's off one side of the transformer, the other side's off the other side, center tap's off the reference. The only way you can get them both turning on and off together is if the center tap isn't working, because, you know, that's the reference point. It goes plus and minus from that, and it's not doing that. They're both coming up together, and the reference is turning on and off. As we know, it's being shorted out every pulse. It's shorting the reference out, which is why the last run is too long now, because it's obviously putting stress on things. So it's like, well, is it shorting the reference out because of these pulses being wrong, or is it the pulses are wrong because the reference is shorting out? So the only way to find out is to break that link. And so what I've got now is I've cut the track on the back of the board which isolates all the flip-flops from the reference, and then I'm injecting my own 20 volt supply, which is what the reference generates. On here we've got the TP4 and TP5. So these should be in phase with each other if it's correctly flip-flopping. Right, so I can verify the flip-flops are working correctly. I'll hook up the full channel as well. Channel 3 is the reference. I'll come back in a second. Alright, so now I've got all four channels set up. So channel 3, which is down the bottom, not here, it's that one. That's DC coupled, so it will do an offset and show the actual output of the reference. The other three channels are AC coupled, so they'll be around the axis of the level there, right? So that way they won't jump off screen, stuff like that. Just easier to manage. So I'm going to start off with my power supply turned off, so there's no reference going to that part of the circuitry for the flip-flops and stuff. So I turn the output on, 1 volt, this is how we get the waveforms you want. And There we go. So these two are out of phase and they should be in phase together. And this one is switching correctly. So channel 4 is indeed switching like it's supposed to be. This channel 4. So that should be switching on when these ones are switching off. They're both supposed to be switching off. This one's wrong, like we know. Let's turn my power supply on. And now turn the power supply on. You'll see these two are now in phase. So channel 1, channel 2 are now in phase. So that means the flip-flops are now working correctly. So channel 1, channel 2 are turning on. Right, so there's channel 4 down here is in the correct phase. So 4 should be opposite of what these two are. So the flip-flops there are working correctly, and yet the voltage out is still wrong. And what you can also see from this is that the output from the reference is still being shunted down. This should not be a waveform here. That should be a continuous 20 volt line. So the reference voltage is still being chopped up, which eliminates a lot of stuff. The voltage out is wrong. So I've now determined that the thing I'm chasing is a symptom, not a cause. So I've just stopped the scope, so it's just sitting there right now with that last captured waveform. I've changed the display. I've now got a DC coupling on all of these waveforms, so we can check the DC offsets to make sure the offsets of the waveforms are correct, because that's also important. Not just the waveforms themselves, but are the waveforms of the right voltages. I've gone through quickly just now and looked myself. So channel 1 should be going between, based on the service manual here, the waveform that's on this page, which I'll show you in a second, should be 0 volts and minus 11 volts. And that is basically what that's doing. Channel 2 should be going between plus 20 volts and plus 31 volts. And we've got a 20 volt division offset, so 20 volts and about half a division, so channel 2 is looking pretty much correct. Channel 4, not channel 3, channel 4 is TP3, and that should be going between plus 20 volts and minus 11. Well, we've got the plus 20 volts on 20 volts of division. They're getting plus 20, but not getting minus 11. It should be going down to this line here. It should be going downwards. It's not. The minus 11 isn't at TP3. We know this waveform's correct here. That's correct there. The minus 11 volts is missing from TP3. Might give us a clue about what's going on. I'm hoping so anyway. Right, so this flip-flop thing I've been trying to chase isn't actually the cause of what's wrong with it. It's another symptom. So what I've actually discovered is that by substituting my own voltage reference signal over here and also in here, that's all off the one track, which I cut the track to and injected my own 20 volt reference to, I get the correct phasing out of this flip-flop at TP5, that's correct, but I've still got the fault present, which means TP5, that inverse waveform I'm getting on flip-flop, wasn't actually the fault. It's just another symptom. So this one here is the output turned off, TP4, 5 and 3 in that order. That's what the waveforms look like. You see tiny little spikes on those, okay? And that's the actual spikes on those waveforms I zoomed right in. You can see what they're actually doing. That channel 2 looks awfully messy, which is interesting. This is at 1.9 volts DC output when it's working. I'd actually have a small phase here where it started working again for a short time. And so I'll grab some screenshots from that. Those are 3 test points, so you can see these are in phase like they're supposed to be. And this is out of phase like it's supposed to be. And this is at 1 volt DC. Channel 2 set AC, so just wait for that. That's why it's offset. Just watch out for that difference there. But that's when it's faulty, so you can see these two are out of phase and they're not supposed to be. And that's when it's working at 1 volt DC. You can see they're in phase. There's zoomed in. Same things again. Just zoomed in, so you can see the waveforms. You can see the slopes on the rising edges. These are the starting ramps. As you can see, there's a delay there in between there and there. There should be a 0.5 microsecond delay between these finishing and this one starting, and there is. And the same for the ending ramp. So the ending's also about the same. There's about 0.5 microseconds between that one and these. So those are correct. This is off the bases of Q25 and Q27. So these are the inputs straight off the coil. So those that they're sensing there. So it's trying to see what's actually coming in, and that's what I was getting on those. So they're both the same. This is before I put the reference on there. So there's no reference signal coming in, and you can see they're both the same phase, and they're supposed to be inverted from each other. So that's why that flip-flop was playing up. When I actually injected the reference, then these did invert, and then this one was going negative, and it was flip-flopping like it's supposed to. Once I put a reference on here, then it worked. So that ruled out that flip-flop. and I started looking at Q19 and Q20, which is this lot up here, Q19, Q20. Now, Q20 is the one that drives the gates of these JFETs down here. If we've got a shorted supply, one of these, or at least one of these pairs, has to be turned on, or there has to be some kind of leakage fault. So I appear to have some progress here. As you can see on the scope, we've got some nice waveforms, nice and straight, as it should be. The bottom waveform here is the output from the reference. As you can see, it isn't jumping around, it isn't stepped like it was before. Now it's a proper consistent waveform, a solid reference voltage like it's supposed to be. Just turn the output on. Should see basically no changes. Some few little spikes in here. That's all looking nice and clean. That's looking like it's supposed to. It does have a compensation for voltage at 0 volts even. So let's put 1 volt on. And there we go. Nice stepped waveforms. Output is still consistent, so the reference is still solid. So this one's stepping up. Channel 1 is on TP4, channel 2 is on TP5, channel 3 is on TP3, as it was previously. And you can see they're all stepping as they're supposed to be. The voltage offsets are correct. Now I did also do some screenshots which I'll probably insert, which showed the voltages on some of the transistors. What I ended up finding is that the flip-flop, as I probably mentioned already, the flip-flop that supplies TP5, that was actually working fine. What it was is because there's no reference voltage at the time the flip-flop's operating, it is causing it to latch up, and it's just doing both outputs simultaneously, which is then causing it to be a bit nonsensical. So TP5 flip-flop was actually fine, nothing wrong with it. But it was another symptom of what was going on. So then I started tracing back to the TP3 system, the very first top one on the page. What I'd noticed on that previously when I did my initial testing is that the voltages didn't seem right. The minus 11 volt voltage wasn't there. And the waveforms are right, but the voltages weren't quite right. And I thought it may be a symptom of the whole thing being pulled up and down, or pulling gates around, that sort of stuff. I went back to that part of it, and I actually noticed that one waveform I hooked up to Q19 and Q20. Q19 and Q20 are the pair of flip-flops outputs, and you expect, because they're the pair and they've basically got identical circuitry, you expect the outputs to be identical. They were different, very different. Phasing was correct, they're opposing switching, but the voltages are wrong. They should have been the same voltages on the output, and they weren't. I tried a few different things, and I ended up replacing Q20, which is a 2N3904, my simple part. That is what's resolved it. So Q20 wasn't actually turning on fully. It was partially switching. It wasn't actually pulling it right down to minus 11 volts, which meant the JFET was never turning off. It was never actually being pulled down to a state low enough to turn the JFET off, because it only went down to like 1 volt, and so it wasn't actually shutting off. So yes, it's working now. It's working correctly. That's great. If I change voltages, shouldn't really see much going on here. Might see some compensation and stuff, but that's about it. This meter's kind of accurate. Yeah, another digit. There you go. It's working. Now I've still got a couple of things I want to do on this calibrator. When I did the original repairs and refurbishment on this thing, there's a few capacitors I didn't have. Quite big bulk caps which go on the main motherboard on the side at the back here, on the board all these cards slot into. I didn't have those capacitors in stock. I've since got them, so before I put it back together again, I'm going to place those capacitors and have that job done. So then it's fully recapped. All the electrics have been done, every single one of them. And obviously all the 25 volt tantalums have been replaced with 35 volt tantalums, the whole thing. So then it's basically fully refurbished. And as long as I don't have any more problems with this, I think we're good. I think that's probably in the repairs. I hope so. But yeah, it's quite good. So I thought I'd show you those waveforms in case you're interested in seeing what's supposed to be on those test points. So what I think is happening, the reason it's getting a higher voltage when the reference is being shorted out, this is acting like an inductor, because there will be some inductance on the board and componentry, that sort of stuff. And you think about how a buck converter or a boost converter works. They short across a inductor in order to create a current build-up, increases the current, and then that's then transferred. So I think that's what's happening, because it's being shunted across, chopping that waveform up, is effectively creating a boost circuit, which is why the voltage was increasing. That's my suspicion anyway. No more glitches so far, so yay! It's fixed. Catch you next time. Subscribe, click the bell icon, thumbs up, all that stuff. Bye.